This is the counting circuit project, Project 3A, the button input. The input of the LED is connected directly to power, therefore when the button is pressed it creates a low, turning the LED off. Project 3B, the NAND gate oscillator with the 4011 chip. When the circuit is at rest, there is a signal on the fourth output of the NAND gate, which means that the LED on the circuit will be off. When you press the button, the power runs through the circuit into the second capacitor. This capacitor is so small that it fills and drains very quickly, creating the appearance that the LED is flashing on and off continuously. Project 3C, the decade counter with the 4017 chip. This chip outputs a high signal on output pins 0 through 9 whenever the clock signal coming out of the previous 4017 chip that we've used in previous circuits hits a rising edge. When this happens, the chip will output a high signal on the pins 1 through 9, and the sequence creates an illusion that the LEDs are counting upwards from 0 to 9. Project 3D, the decimal counting binary up-down counter with the 4510 chip. In this circuit, much like the previous circuit, on every rising edge of the clock input represents by one square wave, the counting device adds by one. The circuit provides a more condensed view of the counting. Project 3E, binary counting decimal decoder with chip 4511, and Project 3F, the 7-segment display. The 4511 chip takes in binary values and displays the equivalent decimal value on the 7-segment display when it is connected. For the circuit to work, pin 11 of the 4510 is plugged into pin 1 of the 4511, and pin 2 of the 4510 is plugged into pin 6 of the 4511. On top of that, pins 3 and 4 are connected to a high power and the 7-segment display. The 7-segment display is really just 7 LEDs lined up in a particular pattern. Each of these LEDs is called a segment because when it is illuminated, the segments form part of a numerical digit to be displayed. An additional 8th LED is sometimes used to indicate the decimal point. The binary brain behind this segment was the 4511 chip, which outputted the numbers that were then represented in decimal numbers by the 7-segment display. This is the binary code decimal chart.